We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello everyone, myself Jai Pandya, Assistant Professor in SHANKERSINH VAGHELA BAPU Institute of Technology, Gandhinagar. Today I am going to take a presentation on a subject called surveying, which is in semester 4 of branch of BE Civil Engineering, and the code of the subject is 3140601. So today's presentation is on modern surveying instruments. Before I go direct towards the presentation topics and today's subject, let me give an overview about the subject surveying. As you are going to study in your civil engineering, that surveying is an important subject. If you are a civil engineer and or surveyor, you need to have the knowledge of surveying and how to perform various type of surveys on the field. So as the name suggests, surveying is to survey about the area or volume or any other measurement criteria. So for the easy of the surveying process, we need to have some instrument with us. So this chapter is dealing with the knowledge of the instrument that we have or we use in surveying. So let's get into the presentation topic. So my presentation topics are as this below: introduction, electromagnetic waves, frequency and wavelength, electromagnetic spectrum, principle of EDM, digital theodolite, total station, and GPS. So in this chapter we will about to study which are the measurement techniques available, which are the instruments are available in the modern era. So let's get to the introduction part. Here you can see in introduction we have 3 distance measurement method to be classified as DDM, ODM and EDM. Full form of these 3 is direct distance measurement, optical distance measurement and electromagnetic distance measurement. In the direct distance measurement, we use chain survey or tape survey, which is an older method and not that much accurate and time consuming method used for surveying in older days. Then optical distance measurement is the observation taken through optical distance measurement instruments called tachymeters, and calculations are done for the distance. However, these tachymeters are not suitable where high accuracy is required. Moreover, their use is limited for shorter sites. And finally, EDM, electromagnetic distance measurement instruments, have been recently developed, which having a higher accuracy in the distance measurement. It is also expensive and also give advanced features like any other method of distance measurement. The modern surveying instruments are digital theodolite and total station. So the working of this type of EDM instruments can be understood by the waves phenomena. So EDM method, it is based on the generation, propagation, reflection and reception of electromagnetic waves. Electromagnetic waves is nothing but the combination of electric and magnetic field which is generated with the waves called electromagnetic waves. As you have know that various waves have various frequency and wavelength. Okay, EDM instruments have the same electromagnetic waves. So with the range of the waves, we have different type of EDM instrument with us. Here, before go to further the principle of the electromagnetic waves, we need to understand what is frequency and what is wavelength. So what is frequency? It is defined as number of cycles of a wave passing a fixed point per unit time, which is normally measured in hertz, Hz. And what is wavelength? It is defined as the distance between two identical points on a wave, measured always in meters and denoted as lambda. Another topic is electromagnetic spectrum. So the figure shows the various waves that we are having, and each waves having how much frequency is listed here, from cosmic waves, gamma waves, X-rays to ultrasonic waves to visible to the microwaves and radio and TV waves have different frequency range and different wavelength also. As per our requirement, we select any of these waves to be used in our surveying instruments. This is a figure of electromagnetic spectrum, where you can see from 10-1 to 10, it is the visible waves towards the thermal infrared waves, which is the, we can see this is for suitable for eyesight, and afterwards all the waves can be used and utilized in the EDM instruments. Then, so how the EDM instrument works, what is the principle of it? So let's get to it. So the principle of EDM instrument is that it calculates the distance by measuring the phase shift during the radiated electromagnetic wave, such as microwaves, infrared wave or visible light waves, from the EDM's main unit, which returns by being reflected from the reflector which positioned at the measurement point. As this you can understand by this figure, the station at A and then another station at B, wave passing through the distance total d and reflect towards the A point from the B point itself. Here the transmitted waves shown in figure. We will note down how much frequency time is required and what is the wavelength. By that we can measure and identify our survey area by using the principle of EDM shown in this figure. Next is our modern surveying instrument, which is called as digital theodolite. As you aware of, we have chain survey in the past days, and also we have tap surveys. So that type of surveys require so much time, and that also not that much of accuracy. So after the time passes and the new technology arrives, we have advanced surveying instruments such as digital theodolite and total station. Let's get to it. So first of all, digital theodolite is a modern engineering instrument for measuring both horizontal and vertical angles. It is a key tool in surveying and engineering work. The theodolite consists of a telescope movable within the two perpendicular axes to the horizontal axis and the vertical axis also. So, when the telescope is pointed at a desired object, the angle of which of these axes can be measured with a great precision. This is the figure of digital theodolite. As you can see, we have a telescope with the screws, and below that the screen we have a mounted screws that we can use for fixing or leveling of our digital light over a tripod. So this is the advanced instrument for surveying purpose. So what are the applications of the digital theodolite? It is listed here to measure the horizontal angle and also vertical angle between 2 points accurately up to the precision of 1 second. 16th part of a degree is called 1 second. To check the alignment of roads, railways, tracks, tunnels and bridges. So as you guys know that digital theodolite is advanced surveying instrument and have a higher range and higher accuracy with respect to the distance measurement via horizontal or the vertical. We can also use this type of instrument in a hilly area, which is quite suitable, and it is used in the valley also. It is used for also measurement of bearings and measurement of horizontal and vertical distance and determination of direction of the true north. A telescope, as you guys saw in the earlier figure, this is our telescope plotted in the digital theodolite. So the telescope, which can rotate or transit through 360 degree about a traverse horizontal axis. So in the telescope, it can be rotated up to 360 degree, which is quite useful for surveying in our degree range or to note down the vertical angle and also horizontal angle. It is movable part of the telescope. So what are various advantages of digital theodolite? So its superior correctness, it is quite a correct measurement given instrument. Internal magnifying optical system, it is advanced system of optical glass that is built in the telescope for the further and much focused surveying. Reading circles is more accurate as compared to other instruments. Electronic readings, repeat readings are not required, suitable for both flat and sloped ground. So it is possible, it is quite easy to perform surveying in the hilly area as it is suitable for slope ground and also not affected with wind or other weather factors. These are the advantages of theodolite. Now move to the next our instrument. It is called total station. Total station is a surveying equipment combination of electromagnetic distance measuring instrument and electronic theodolite. It is the advance of the digital theodolite, which is combination of electromagnetic distance measuring instrument plus the electronic theodolite. It is also integrated with microprocessor, electronic data collector and storage system, which is quite advanced instrument for the surveying purpose. The instrument can be used to measure horizontal and vertical angles as well as sloping distance of object to the instruments. This is the figure of total station. and below other figure is showing the primary features of the theodolite. As you guys see, various elements have various use. It is also having a prism, telescope, electronic leveling system, screws, holding agents, then also having a digital functional screen, or you can see LCD screen. It is used to measure for the vertical angle distance or horizontal angle or also distance, and it is quite useful. And we can also set primarily before surveying, we can also set up our station and make a default angles measurement setup. So it is advanced instrument, as you can see. So what are the capabilities of total station? Microprocessor unit in a total station processes the data collected to compute average of multiple angle measured, average of multiple distance measured. So the thing is, let's select an area, and then the area is very larger. Then you have to use total station and plot some of the points or station point, as you can say. So we have to carry or put our total station throughout the various type of station, and then by the measuring of angles, we can note down the total distance by the angle measurement. So for the larger area, it is very useful and easy to operate and easy to do our carry forward our survey process. Also, distance between any two points can be identified or can be measured by total station. Also, elevation of objects, how much the elevation of the object can also be measured by total station, and all the three coordinates of the observed points. So these are the capabilities of total station. Another figure showing each and every part of the total station. So from the first, that is our handle, then handle screw, then data input, then battery cover, instrument height mark, base plate, all the features that shown in this figure of the total station. There are up to 29 various features and elements that can be used in the total station, from various screws, focusing screws, to various base plate and eyepiece and glasses, all are equipped very well in the total station. Then these are the advantages of using total station. First is field work is carried out very fast, accuracy is quite high, manual errors involved in reading and recording are eliminated, which is a quite impressive that errors can be neglected and can be eliminated while we are doing survey. Calculation of coordinates is very fast and accurate. Even corrections for temperature and pressure are automatically made. So if you doing your survey in summer or any other weather condition, it is quite a neglectable thing that you can easily survey in any seasons while using total station. Computers can be employed for map making and plotting contour and cross sections. Contour intervals and scales can be changed in no time. And these are the disadvantages of total station. It's not that much. Instrument cost is high, skilled personnel is necessary for carrying out survey, and maintenance and repair cost is high. These are the disadvantages of total station. Then the last topic of today's lecture, it is GPS. The full form of GPS is Global Positioning System. All heard about this. The GPS system Originally, Navsar GPS is a satellite-based radio navigation system owned by the United States government and operated by the US Space Force. It is one of the global navigation satellite system GNSS that provides geolocation and time information to a GPS receiver anywhere on or near the earth where there is an unobstructed line of sight to 4 or more GPS satellites. Obstacles such as mountains and buildings block the relative weak GPS signals. This is the imaginary figure for the GPS system. So, using the satellites that is in the space, there are various type of satellites used in the GPS system. Then the signals transmitted to the receiver shown in the figure, and the data that collected by the satellite, whether it is in ground or whether it is water or whether it is in mountain area, all the recorded data transmitted to the GPS receiver signals. So there are three main functional segments of GPS listed as below: space segment, control segment and user segment. So in the space segment, containing various satellite for GPS use. Then in the control segment, it is on the ground tracks and the maintenance of the satellite in the space. And the user segment, the users friendly segment, it is composed of hundreds of United States and military uses and for the tens of millions of civil, commercial and scientific users of the standard positioning service. So these are the functional segment of GPS. These are the advantages of GPS. It is convenient, reliability is higher, traffic and weather up-to-date live alerts, higher accuracy, higher range, and also can be works day and night. So today's topic of modern surveying instrument is covered. Thank you very much.